Acceleration is how velocity changes. So when you're looking at velocity, that's how fast something is traveling, but you have to realize that sometimes how fast changes. So for example, I have here my cheetah who starts at not moving at all, and after a second is walking at about 3 meters per second. And then from the first second to the second second, goes up to 30 meters per second. Then, for the third second, is at 7 meters per second. Then he finds his prey, tackles it to the ground, and is completely stopped at 4 seconds. So acceleration is a way we describe how this speed changes through time. We basically have some math problems here. All right, so what happens is if you're going from 0 seconds to 1 second, then the amount of time that's passed is 1 second. So the formula for changing acceleration is final velocity minus starting velocity divided by the time it takes to make the change. So here, if I'm looking at just, let me just put up a little thing here. If I'm looking at just, move this over here, come on, not like me. I'm looking at just this little bit right here, then I am looking at a final velocity of 3 meters per second, a starting velocity of 0 meters per second, and it's over 1 second because there's only 1 second of distance here. And that ends up being 3 meters per second per second. Now that is a positive number because this cheetah is getting faster. And it's important to notice that it has to be the final velocity first. Otherwise, you end up with a negative number, and that means something else. So here, our next example problem is if we're going from this second here. So that would be if you were taking 30 meters per second, which is our final velocity, minus 3 meters per second, that's our starting velocity, divided by 1 second, because we're only, even though it's the second, it's still only 1 second between these two spaces here. So that leaves us with 27 meters per second per second. Now let's look at one that has a larger window. Let's look at from 70 meters here back to the 3. Let's look at the change of speed in this section. Here, that would be 70 as our final velocity, 3 as our starting velocity, so we have 70 minus 3, and then we take that divided by 2 seconds because we have 1 second here and 1 second here for a total of 2 seconds. 70 minus 3 divided by 2, that's 33.5 meters per second per second. Now all of those again, those are positive changes because the cheetah is getting faster. As you look again over here, this one's a little bit different. This last second is a bit strange in that the final velocity is 0 meters per second. Now, sometimes in story problems that I give you, I will say that something has stopped. Stopped is 0 meters per second. So here we have the cheetah tackling its prey to the ground. The prey's dead. That's stopped. So we have 0 meters per second minus 70. That's going to give us a negative number. All right? And that's important because that negative number means something. So we have the negative 70 divided by 1 second, and that ends up with our negative 70 meters per second per second. And what that negative sign means is that it's not speeding up, it's instead slowing down. And if you think about it, as the cheetah comes to a stop, that's slowing down. So you have to be careful that you always do these in the correct order. Final velocity minus starting velocity divided by time. Because if you mix them up, then you might get a positive number when you need a negative number or vice versa. So that's that. Now, acceleration happens when things speed up, slow down, or change direction. In this class, we're usually going to give you examples of things speeding up or slowing down. We're probably only going to give you word problems that have changed direction, but no actual math. Sorry about that. Words that are often used in place of acceleration include speeding up, accelerate, slow down, decelerate, negative acceleration, turning. All of these words here, all of them, are words that are used instead of acceleration. Decelerate and accelerate, they mean the same thing scientifically. In fact, decelerate really isn't a science thing. It's only a word that's used for like regular people life, but not really in science. It's not really a science word. Okay. And oops, here's what I wanted. I wanted undo. And then the last slide. The label for acceleration is meters per second, or it's meters per second squared. Now, this kind of trips some students up on occasion because what it is, it's how much speed, that's how many meters per second, actually changes in 1 second. So what you've got is you've got meters per second, and that is why that label works that way. Even if you go back here to the very first one, meters per second changed in a second. That's how that works. So that is acceleration. And I'll turn off the thing.